Let's take a look at some data, and we're going to talk about the normal distribution. So here we have some raw data on the left-hand side here, just a list of numbers that have been recorded from some experiment. And what you might notice is the mean, the mode, and the median are all 50. They're all the same. That's going to be important, and that's going to determine that it is normally distributed data. So we put it into a frequency distribution using 5 classes, and here is the distribution. You can see that we have some symmetry going on here. So this central class has 7 and then 4, 1, 4, 1. And if we graph this on a frequency distribution chart here, you'll see that it is symmetrical. You can kind of follow it around, and it's starting to make the bell curve shape, which is normal for normally distributed data. So it is a symmetrical distribution with half the values are going to be lower than the mean and half the values are going to be greater than the mean. And if we actually draw a curve on this, you'll see it's starting to take that bell-shaped curve, and it's called a bell-shaped distribution because it's shaped like a bell. It's also known as the normal distribution. And here's our mean, median, and the mode is also 50, and half the values are above that, half the values are below that. And that's all a normal distribution really is a symmetrically distributed set of data where half the values are lower than the mean and half the values are higher than the mean, and they were symmetrically distributed. So you'll see the block here on the left is the same distance from the mean as the block on the right. Now, it can take different heights as far as the shape of the bell curve. So here we have a low bell curve, which means the data is spread out from the mean pretty far in either direction. And here we have a very tall, skinny bell curve where the data is clustered very close to the mean. This dotted line represents the mean, and either one of these is considered a bell curve or a normal distribution because half the values are below the mean, half the values are above, and they're symmetrically distributed. In other words, the shape of the bell is the same on the left as it is on the right. And if you recall, the standard deviation is what tells us how spread out the data is from the mean. So our tall, skinny bell curve has a smaller standard deviation, while our low, wide bell curve has a large standard deviation. In other words, the data is spread out further from the mean. So that's it for normal distribution, just a symmetrically distributed set of data. And a good check is if you have the mean equal to the median, you're pretty sure you've got a normally distributed set of data.